Hi, I'm Jim Cates. I'm a psychologist, and this is the fourth in a series of lectures on human development. This is continuing the series on epigenetic theories, and this is looking at the theory of Jean Piaget in particular, and cognitive developmental theory. As usual, let's start with the case vignette. Let's look at Vivi, age 3. Every afternoon after preschool, Vivi watches about an hour of TV. Usually she watches a couple of episodes of Dora the Explorer. And Vivi's language skills and pretend play have blossomed over the past few months, and her parents attribute this to her exposure to Dora. And they have now decided to allow Vivi's 6-month-old younger brother to watch Dora with her, because they believe he will start talking even earlier because of this exposure. Well, cognitive developmental theory provides insight into the quality of thoughts of infants, children, and adolescents. And it takes into consideration the qualitative shifts in thinking and reasoning that occur at various stages. Many parents make decisions about toys, games, etc., and are trying to promote optimal development for their children. But without a theory about children's cognitive development, they end up shooting in the dark. So how do we make sense out of that? Well, first of all, we have to have a definition of cognition. And cognition, for Piaget, or cognitive developmental theorists at least, is the process of organizing and making meaning out of experience. And any information that we analyze, be it visual, auditory, motor, a synthesis of these, needs to make sense of it and is going to require cognition. And per Piaget, every organism, as they try to make sense out of information, as an organism uses whatever cognitive form it uses, strives for equilibrium. And equilibrium is a balance of organized structures. And those structures include motor, sensory, and cognitive. And if these structures are in balance, then it offers effective ways of interacting with the environment. But if these structures are not in balance, if there are changes in the organism or the environment that require changes in these structures, the organism is thrown into disequilibrium. And for Piaget, there are two types of equilibrium. First, there are operations that form systematic, logical structures for comprehending and analyzing experiences. And those operations need to stay in equilibrium. Second, there are schemes and operations within those systems themselves, and those need to stay within equilibrium. So knowing is an active process of achieving and re-achieving equilibrium. When disequilibrium occurs, there's a process of knowing that is an active process that allows one to achieve and re-achieve that equilibrium. So equilibrium is not a constant state. Disequilibrium is a given that occurs and must be addressed. And each new experience that we have, or any organism has, changes knowing, and hence changes equilibrium. So there's an ongoing process of re-engaging, of redetermining equilibrium, of finding equilibrium once again. All right? let's talk about historical context for just a moment, and then we'll talk about some of the stages. Jean Piaget was born in Switzerland in 1896. In his early life, he showed talent as a naturalist, and he ended up earning his doctorate in 1918 with a dissertation on all things about mollusks. But he believed that the principles of biology could explain the evolution of knowledge as well. So from 1918 to 1921, he began working with a scientist named Theodore Lipps, and he was studying empathy and aesthetics. He then went on to study with Eugene Bleuler in psychiatry, and he learned the techniques of psychiatric interviewing with Bleuler. He then went on to work in the Sorbonne in Paris with Alfred Binet, who of course pioneered intelligence testing. And his observations and his interviews in psychiatric interviewing and intelligence testing provided the basis for his first articles on the characteristics of children's thought processes. He moved on to become the director of the Institut Jean-Jacques Rousseau in Geneva, and there he was able to pursue deeper investigations into children's cognitive development. And he went on doing this through the 1920s and 1930s and began to publish his research. Interestingly enough, his work remained largely unknown in the United States until the 1960s, when his work was finally translated into English. And at the time, learning theory and behaviorism were dominant in psychology. Standardized IQ testing was really the focus when it came to children's cognitive processes. We were interested in what children knew, not how they knew it. So the IQ testing was about how smart are they. We didn't care how they came to be smart. We didn't care what the cognitive process was as much as we cared what they knew. But Piaget's work revolutionized the way that scholars and eventually educators thought about the development of learning. So what are some of the key concepts that come about from Piaget's work? Well, first of all, he assumes that the roots of cognition lie in biological capacities. That's why he's among the epigenetic theorists. And he believed that logical thought unfolds in a series of biologically guided stages that emerge in a fixed sequence as a person engages with and explores the environment. This whole process of knowing that moves equilibrium into disequilibrium and back into equilibrium occurs in a series of stages. And he came up with the idea of schemes. So schemes are the structure or organization of actions as they transfer or generalize by repetition of similar or analogous circumstances. What does all that mean? So actions develop in structures or organizations. We make sense out of what's happening. And they're transferred or generalized by repetition into similar or analogous circumstances. We make sense out of what happens as it happens over and over again and create structure and organization out of it. Those are our schemes. And he refers to scheme rather than concept because it can be used just to describe interrelated groups of actions as well as ideas. For infants, there are sensory motor schemes. And this is the counterpart of concepts and conceptual networks before language and other symbolic systems develop. So he believes that infants develop schemes for people, for objects, and for actions. This is how infants distinguish between familiar and unfamiliar people, That's a scheme, that's an organizing principle for infants. You're familiar, you're not familiar. There's an organizing scheme. They can distinguish between foods they like and they don't like. I like that food, I don't like that food. There's an organizing scheme. There's a structure. They can distinguish between sounds that will bring a caregiver and sounds that won't. Simply babbling or cooing may not bring a caregiver, but a loud cry will. So babbling, no caregiver. Loud cry, caregiver. They can structure those concepts, organize them. Another key concept is organizations. All living organisms organize their various structures into a coordinated or integrated system. That occurs at a biological level. There are respiratory, circulatory, digestive systems. These are all organized. At a psychological level, individuals organize visual, auditory, proprioceptive, motor systems to achieve a goal. And organization occurs at a cognitive as well as a behavioral level. We develop categories of items. For example, categories of fruits, categories of animals, categories of family members. Those are all examples of how organization works. And they serve an adaptive function by reducing the amount of information needed to respond to individual stimuli. If we know that these are all family, we can group them rather handily. We don't have to consider them as individuals and come up with rationale for who they are or how they are. They fit into a scheme, they fit into an organization that's concise for us in a way that otherwise would not be as concise. So adaptation then, for Piaget, is a gradual modification of existing schemes to take into account the novelty or uniqueness of each experience. And there's some similarity here between this use of adaptation and its use in evolutionary theory, which we discussed a couple of lectures ago. Here, it works to produce modification in the capacity for logical thought. And it's also a two-part process. There's continuity of existing schemes, and there's the possibility of altering existing schemes. One part is assimilation, and that's a tendency to interpret new experiences in terms of existing schemes. So, if my sister is getting married, I have a brother-in-law who now becomes family, or a sister-in-law who now becomes family. So that person is integrated into an existing scheme. The other part is accommodation, and that's a tendency to modify familiar schemes in order to account for new dimensions of an object or event that are revealed. So I may have to change the scheme to accommodate new information. And we gain knowledge across the lifespan through the processes of assimilation and accommodation. And cognitive development proceeds through a back and forth process. We end up comparing new experiences to what's already known, making modifications to take into account the new information, and then revising schemes to guide subsequent encounters with the new environment. So how does this fit then with stages of development? Well, Piaget considers a fundamental pattern of cognitive maturation that's universal. At each stage, there's a set of mental operations that form structures that underlie this sense of knowing. with a sense of knowing, equilibrium, disequilibrium, staying in a stage of equilibrium. So in infancy, there's a sensory motor scheme. In later stages, organized mental operations provide a foundation for organizing and interpreting experiences, but sensory motor intelligence here lasts from about birth to 18 months. And it involves the formation of increasingly complex sensory and motor schemes. Reaching and grasping. Again, we've talked about in previous lectures, the ability to put a finger in an infant's palm and they'll immediately grasp it. There's a sensory experience. That becomes part of this whole sensory motor scheme that develops. If you watch an infant's eyes as it learns to follow an object, that becomes part of that whole sensory motor scheme. But as they do so, as they have these basic sensory motor experiences, they develop a means-end relationship. So to start with, they'll kick, but they find that if they kick and hit the side of the crib will shake. And they enjoy the newfound ability to make the crib shake. There's a means end. If I kick the crib will shake. So they kick the crib. They do so back and forth, back and forth. If there's a mobile hanging in the crib and they kick the crib and the mobile begins to move, again, means end. Their behavior begins to create something that occurs. This whole sensory motor stage, it may not have language attributed to it or symbolic thought that they can attach, but they're beginning to create schemes. They're beginning to organize their experience. From there, they go to pre-operational thought. And that lasts from about 18 months or so to 5 or 6 years old. And there they begin to represent actions with mental images. There's symbolic representation of schemes through language, imitation, mental imagery, symbolic play, and symbolic drawing. But knowledge is still very much tied to their own perceptions. They don't have a lot of knowledge about things beyond what they can perceive, what they have experienced, what is in their immediate range of knowing, what they have personally had experience with. They can't conceptualize things beyond them. So it's pre-operational in the sense that you can't explain things to them that are requiring abstract thought. Pre-operational. But it's a transitional period in that schemes developed in infancy are beginning to be represented internally. So the foundation for abstract thought is being laid. Next is concrete operational thought. It goes from about ages 6 to 7 to age 11 to 12. And children are beginning to appreciate the logic of causal relationships. And they're beginning to manipulate categories, classification systems. They're beginning to create hierarchies and groups. But it's called concrete because children are still more successful in solving problems that are clearly tied to physical reality than they are in generating hypotheses about purely philosophical or abstract concepts. Their operation refers to an action performed as an object or a set of objects. And mental operation that's transformational is carried out in thought rather than in action. They're beginning to use internalized thought much more, but they're limited in the extent to which the quality of thinking and hypothetical reasoning can extend. It's not now limited to only what they have experienced, but the boundaries are still somewhat tangible. For example, Children can reason out a problem of grouping trees into different categories. If I said, I want you to tell me where these trees belong, and you handed them pine trees and you handed them oak trees, pictures, and said, place them together. They could put oak trees with oak trees, they could put pine trees with pine trees. But they'd have more trouble identifying variables that relate trees to other forms of life. So if you said, here's bacteria, insects, mammals, and trees, group the trees with the group that they best go with, they would have more trouble abstracting that kind of information and figuring out which group the trees would go with. That's a much more abstract, philosophical kind of perception, and they would have difficulty with that at a concrete operational stage. Formal operational thought, though, begins at about 11 or 12 years old and continues through adulthood. And the qualitative skills in cognitive processing that begin here and go through adolescence are developing and moving. In concrete operational thought, children are going to use mental operations to explain changes in tangible objects and events, oak trees versus pine trees. In formal operational thought, young people use operations to manipulate and modify thoughts and other mental operations. So the central feature of formal operational reasoning is the ability to separate and distinguish between reality and possibility. So an important characteristic of formal operational thought is the ability to raise hypotheses to explain an event and then follow logic that that particular hypothesis implies. So for example, if I said to a high schooler, I want you to write a paper about what America might have been like if the Pilgrims had not landed for another 100 years. That high schooler has the ability to conceptualize and to think about and to create an experience in her or his mind about what that would be like, and to set in motion a series of abstract hypotheses about what could have happened and what the landscape might have looked like and what the interaction of cultures might have looked like, and set up an entirely different possibility and come up with realistic possibilities because they can think in that abstract and philosophical way. So that would be the difference. What new directions? Where has Piagetian theory taken us? Well, there's an enormous amount of theory and scholarly research extending from Piaget's work. One area in particular has been moral reasoning. Piaget considered a major transition in moral judgment as the shift from heteronymous to autonomous morality. In heteronymous morality, rules are fixed and an unchangeable aspect of social reality. In autonomous reality, children see rules as a product of cooperative agreements. And Kohlberg developed stages of morality based on Piaget's work. And the first stage for Kohlberg is pre-conventional morality. It's simply based on punishment and reward. If I do this, bad things happen to me. If I do this, good things happen to me. Therefore, I don't do this and I do this. It has very little to do with any kind of sense of morality. It has to do with the consequences that occur to me. Conventional morality is concerned with maintaining approval of authority or maintaining social order. There's an awareness that things should occur in certain ways to keep society running smoothly. Post-conventional morality brings an acceptance of moral principles that are viewed as part of a person's own ideology, rather than simply something imposed by social order. And that's considered the highest level of moral development. Longitudinal studies have generally supported Kohlberg's moral cognitive model, but they find that moral behavior is often based on an emotional reaction to a situation. It's followed by a slower process of reasoning, so that very often we morally react in the moment on the basis of emotions, and later on the basis of a moral code. So what are the strengths and weaknesses of cognitive developmental theory? One of the strengths is that it's a rich body of descriptive data about how children behave and what they understand. And it's given rise to a great deal of research. So from the point of view of a good theory, Piaget's work has had an enormous impact. The strongest criticism has been that cognition is much more variable than a strict stage approach implies, and that children and adolescents solve problems in different ways depending on the domain, and also that children in a specific age group are much more variable in their cognitive capacities than one might expect. There's also some evidence that Piaget underestimated the cognitive capacities of infants and overestimated the cognitive capacities of adolescents. But still, one of the primary influences among developmental theories